My dear students, in our previous video, in the topic logical statements, that means mathematical logic, in that topic we have seen some various statements, namely consequences. The statements are converse statement, inverse statement, and contrapositive statements. We have seen these statements with examples. Now in this video, I am going to continue that exclusive or, exclusive or, it is denoted by EOR. Exclusive or, that is truth statements P and Q. Exclusive or is denoted by disjunction symbol with bar. P exclusive Q. P exclusive or Q. The two statements P and Q are exclusively connected. This condition for this exclusive or means the truth value of P exclusive or Q is T whenever either P or Q is T. Either P or Q has truth value T, then P exclusive or Q is also T. We will see the truth table for exclusive or. P Q, P exclusive or Q, P T T F F, you know that the entries on P, and Q is alternative T and F, and P exclusive or Q, by this definition the truth value of P exclusive or Q is T when either of P or Q is T. Either P or Q is T, the truth value is T, otherwise F. This is the truth value of truth table for P exclusive or Q. Okay, next we will see tautology, contradiction and contingency. Next we are going to see tautology. What do you mean by tautology, contradiction and contingency? This is exclusive or truth table. Now we will pass on to the next concept. Tautology. Next concept is tautology, contradiction and contingency. What do you mean by tautology? In a truth table, the final column, the extreme column consisting only truth value T, then it is called a tautology. In a truth table, the final column, all the true values are F, then it is called contradiction. And in the final column, the truth values T and F are alternatively or neither T or nor F exclusively, then it is called contingency. In the contingency type, the extreme column consisting of both T and F. First we will see tautology. Tautology, for this you consider this example. Construct the truth table for P exclusive or Q disjunction P exclusive or negation Q. Disjunction P exclusive or negation. We will see the truth table for this statement. P, you know, T, F, F. Q is alternatively T and F. And the negation P, negation of Q, negation of Q. T is replaced by F, F is replaced by T. This is negation Q. Next, P exclusive or Q. Just we told the P exclusive or Q. We see just before we have seen that P exclusive or Q is having truth value T if either of Q or P is T. If both are T, exclusive or is false. Either one is T, truth value is T. Either one is T, truth value is T. Both are false. The truth value is false. This is P exclusive or Q. Next one, P exclusive or negation Q. Negation. P exclusive or negation Q. P negation Q exclusive or. P negation Q. Negation Q exclusive or means either one of T is T, the truth value is T. For exclusive or T, negation Q is F, therefore T. Next T, both are T, therefore false. Both are F, it is false. P is F, negation Q is T, therefore the truth value is T. Now we will consider the required condition. P exclusive or Q, disjunction P exclusive or negation Q. For these two, we want conjunction. Disjunction. Disjunction means either one is T, the truth value is T. And both are T, the truth value is T. 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 Either one is T, the truth value is T. Either one is T, truth value is T. Both are F only, the conjunction is, disjunction is F. If both truth value P and Q as having truth value F, the disjunction is F. But in this case, either one of is T, the truth value is T. Therefore, the last column consisting of all truth values is T. Therefore, the given condition is a tautology. So that's all. This is tautology. Therefore, P exclusive or Q, disjunction P exclusive or negation Q is a tautology. Tautology. Tautology is denoted by. Tautology is denoted by the symbol like that, T. Next, we are going to see the contradiction. Example for contradiction. Contradiction means in the final column, extreme column of a truth table consisting only F, truth value becomes only F. If it is, then it is so, it is a contradiction. For that, you will consider the same example. Instead of disjunction, you take conjunction for these two. You know P, Q, negation Q, P exclusive or Q and P exclusive or negation Q. For these two value columns, we want conjunction. We have seen disjunction in the previous case. Now we will see conjunction. Conjunction means if both are T, the conjunction, both expressions P and Q has truth value T, then only the conjunction is T, otherwise F. See, for this conjunction, either one is F, the truth value is F. 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 Both are T, only the conjunction is T. Therefore, in the final column consisting all the truth values are F, Therefore, the given expression P exclusive of Q, conjunction P exclusive of negation Q is a contradiction. Is a contradiction. Contradiction is denoted by the symbol capital R. That's all. Okay. Next we will see example for contingency. Third one. Example for contingency. For that, you construct a truth table for P biconditional statement Q, conjunction negation of P single condition negation Q. P biconditional Q, conjunction negation of P single condition statement negation Q. We will see P, Q, negation Q. We have the same three columns. We have P, T, 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 F, F, Q is T, F, T, F. Alternatively, negation Q. We want here, therefore, F, T for F, F for T, and P biconditional statement Q. P biconditional Q. So biconditional means if any one of both are T, the truth value is T. For biconditional, both value P and Q are T, the truth value is T. Anyone is F, the truth value is F. Biconditional, both are T, truth value is T. Anyone is F, truth value is F. Anyone is F, truth value is F. Both are F, truth value is T. This is biconditional. Both are T, P and Q are T, truth value is T. Anyone is F, the truth value is F. Both are F, the truth is T. Next, P single condition negation, P single condition negation. This we want. Next column, single condition, you know that first statement is T, second statement consisting of the truth value F, then the truth value is F. First condition T, first statement T, second one is F, then the truth value is F. For this is P and this is Q. P single condition Q. First one is T, second one is truth value F, then the P single condition Q is F, otherwise T. Other rest of all the three items are truth value T. Therefore, P negation Q. P negation Q. First value T, second one is F. This case, first one P is T, negation Q is F. Therefore, the single condition is F. First one is T, Q is F, therefore single condition is F. T, T, truth value T. Ft is also T. Ft is also T. First one T, second one is F, only F. Next, otherwise T. Okay, F is also T. T is also T. Ft is also T. Next, for these two, we have the conjunction. P biconditional Q, conjunction. Negation of this is also we want, isn't it? Next one is also, we want the negation of P single condition negation Q, we want a negation of P, single condition negation Q. For this statement column, we want the negation. For that, if it is F is T, T is F, T is F, T is F. Negation means alternate. F is T, T or F, P. Just by F. Next, for these two only we want conjunction. You consider these R, this column by S. We want the conjunction for R and S. We want the final column conjunction for R and S. Conjunction means both are the only T. This is FT is F. What is it? R is not this is R. Sorry. Because P by condition is P by condition Q is R and negation of P, single condition negation Q is S. For these two only we want conjunction or conjunction S. This is T and this is T. Both are T. Conjunction is T. Both are F. Conjunction is F. Both are F. Conjunction is F. TF is also F. See, both having T, then the condition is T. That's all. The rest of the things are false. Therefore, the final column consisting of both T and F, therefore it is an example for contingency. The final column consisting of both T and F, therefore P by conditions negation Q, conjunction negation of P single condition negation Q is a contingency. That's all the example we have derived: tautology, contradiction and contingency. And one more thing I am going to insist: a statement P and its negation, that is disjunction of a statement and its negation is a tautology. I will say one thing. Let's all go to the example of contingency next. The disjunction of a statement and its negation is a tautology. The disjunction of a statement and its negation is a tautology. The disjunction of a statement P is having T and F, truth values. Negation P is F and T. Negation P is F and T. Disjunction of P and its negation P. Disjunction means anyone is T, the value is T. So see this. The disjunction of P and its negation. Disjunction of P and its negation is a tautology because final column is T. Okay. Similarly, the conjunction of a statement, it is a tautology. Next one. The conjunction of a statement and its negation is a contradiction. The conjunction of a statement and its negation is a contradiction. In this case also, P and negation P are given. TFFT. Now, see, this is tautology is conjunction. This is tautology first. Now, conjunction. Disjunction is tautology you proved. Now, conjunction. Conjunction is defined by the symbol T and its negation P. Conjunction is both are T, only T. Either one is F, the truth value is F. So it is a contradiction. Therefore, we have seen first table, we have seen P, disjunction, negation P is a tautology. That means this is the symbol. And now P, disjunction, negation P is a contradiction. For this is the second table, it is denoted by, that's all about tautology, contradiction and contingency. And we will continue the remaining concepts in the next video. Thank you.